Okay, welcome back, guys. So, I think it's part 5, right? So, today we will deal with very simple topic, principle of method of mixtures. What? Principle of method of mixtures now, right? In this case, the definition is very simple. If you look into the definition, it says net heat lost by hot body. So, suppose if you consider a hot body, let's say, right? So, the hot body, name of the hot body may be A. It is at a temperature of 70 degrees centigrade. And we will consider one more body here, B, right? So, this body is at 20 degrees centigrade, right? Now, this principle of method of mixture says when these two were in contact with each other, as you guys know, we have studied before, that is about the thermal equilibrium, that when two bodies were in contact with each other, what happens? There might be transfer of heat energy takes place from body at higher temperature to body at lower temperature. Wonderful. Now, if you observe carefully here, what happens is this is object A and this is object B, right? So, now what happens is this is 70 and this is 20, right? So, when it comes here, if you consider, if you do an average to this, 70 plus 20 is 90 by 2, it's nothing but 45 degrees centigrade. Yes or no? So, they both comes to the 45 degrees centigrade, which means to come to 45, object A just lost some temperature, right? Let's say 70 minus 45, let's say it's 10 minus 5 is 5 and 6 minus 5 is 25 degrees centigrade. So, it loses 25 degrees centigrade, right? It loses 25 degrees centigrade, and if you consider this case, right, to come from 20 to 25, it gains 25 degrees centigrade. Yes or no? So, from this principle of method of mixture, we simply say net heat lost by hot body, that is nothing but A, lost by A is equals to net heat gain by object B, right? So, if you consider these two cases, it loses 25 and it gained 25, which means the loosed 25 degrees centigrade gets transferred to the object B, then they both attain the same temperature, right? So, from this, you know this, right? Principle of method of mixture says net heat lost by hot body is equal to net heat gained by cold body. Is it clear? From this, based on this, we have 3 cases now. Okay, we need to observe those 3 cases. Firstly, let's start with this. Let's take 2 bodies here. One is a hotter body and the other one is a colder body. Let's say these two are hotter liquid and a colder liquid, hot water and cold water, right? So, after they both get into that temperature, as you guys know, heat has a formula, Q is equal to Ms delta T, right? So, in this case, I simply assume like this, hot body has a mass of M2 and it has a specific heat of S2 and it has a temperature of T2, right? Let's assume it is in the beginning state, right? Cold body has a mass of M1, cold body has a specific heat of S1, it has a temperature of T1, right? Let's consider like this, because I had taken M2 for hot body and M1s and S1s for cold bodies, because the object is in the initial position, it is at colder state, right? While you guys have increased the temperature, what happens is it becomes M2, right? There might be change in mass happens, there might be change in specific heats happens, and there might be temperature differences also happens. Yes. Now, what I did was very simple thing. I just wanted to mix the hot water with the cold water, right? When I mix these two, right? When I mix hot water and the cold water, we got a new temperature. Yes or no? In this case also, when I mix 70 and 20, we got a new temperature. Yes. In the same way, when I mix T2 and T1, I got a new temperature, I will call it as a T, right? So, from this, we have something here, right? That is, from the principle of method of mixtures, we say net heat lost by hot body is equals to net heat gained by cold body. Here, so hot body, net heat lost by hot body is equals to net heat gained by cold body, that is Q2 is equal to Q1. From the formula, as you guys know, Q has a formula, that is M S delta T, right? In this case, for Q2, we have masses. M represents M2, S represents S2, delta T represents, right? There might be change in temperatures happens, right? Delta T. In this case, for delta T cases, we are going to write like temperature differences, that is T2 minus T1, right? For this case, if you consider hot water involved, hot water is present in this case and also this case, right? Hot water is not present here, yes? So I would like to write the difference between these two. So I simply write M2 S2 in place of delta T. I am going to write T2 minus T1. Okay, T2 minus T, right? I just write like this, which is equals. Now, if we come to this case, it becomes Q1. Q also has a formula, that is MS delta T. In place of this, I am going to write like this, M1 S1 in place of delta T. Now, cold water is present here, T1, and cold water is also present in this case, right? So, in this case also, I am going to write like this, M1 S1 into, I think, T minus T1. Okay, I had written T minus T1, that's because, let's say, T2 has a 100 degrees centigrade, T1 has a 20 degrees centigrade, and when we mix these two, we got a new temperature, right? Yes or no? So we got a new temperature, that is 100 plus 20 divided by 2, which means 100 plus 20 is 120 by 2. It is half of it, will get 60, right? In simple terms, which means it is greater compared to this case, right? So I simply write T minus T1. Yeah. Now based on this equation, we are going to derive some formulas for this, right? Let's say this. We have a case 1. Let's consider like this. Let's say for case 1 we have masses. Those masses were not equal. Specific heats of the substances were equal and the temperatures were not equal, right? Let's assume like this. In this case only specific heats were equal now. So we'll write the same equation that we have derived here, that is M2 S2 into T2 minus T, that is equals M1 S1 into T minus T1, right? If you observe these cases, M2 S2, as you guys listen, there is no changes, wonderful, M2. But in this case, in place of S1 and S2, I am going to put S for both the cases, right? So in place of S2, I am going to put S, T2 minus T is equals M1 S1. So in place of M1 and S1, M1 S T minus T1. In both the cases, S and S got cancelled out, right? So let's multiply with M2 on both the cases, with M1 on here, M2 into T2, M2 T2, here plus into minus M2 into T, M2 T, that's equal. In place of here also plus here M1 T, and plus into minus M1 T1. Yeah. Now we'll send T terms to one side and T1 T2 terms to the other side. Let's say now we'll send M1 T1 to the other side, which becomes M2 T2. If minus goes that side, it becomes plus M1 T1, that is equals, in place here M1 T here plus M2 T. Okay, so here I think it looks like you could make T common, T into M1 plus M2 is equal to, here just write like this, M1 T1 plus M2 T2, right? So M1 plus M2 is multiplying T, just send this to the other side. What might be going to happen? It looks like, let's write the equation T is equal to M1 T1 plus M2 T2 divided by, overall we got a final formula M1 plus M2. I think you might have heard this formula, right? I think you might have heard this formula. This formula is very, very important for the sums, right? So this case is very important. So let's say here T is equal to M1 T1 plus M2 T2 by M1 plus M2. Clear? So this is one of the formula. Let's write this formula here. Okay. So this is very important. Okay. If you wish, you could easily note it down. So I would like to write like this. For case 1, we got a formula, T is equal to M1 T1 plus M2 T2 by M1 plus M2. Okay. The usage of these formula will be Okay, I will tell you about this while doing the problems now. Okay, so we just dealt with case 1, right? Let's assume this is case 2, right? In this case, we'll interchange something, that is, we'll make masses equal, and in this case, we make specific heats were not equal and temperatures were also not equal, right? There might be little changes happens. Let's see. Now in this case, if you observe this case, now in this case, here masses were equal, right? I'll put in place of m1 and m2, I'll put only m. Now it becomes ms2 into t2 minus t is equals here m s1 into t minus t1, right? In both the cases, got cancelled out. s2 into t2, s2 t2 minus s2 into t, s2t is equals s1 into t, s1t minus s1 t1. Clear? Now I am just going to send t terms one side and t1 t2 terms on the side. Let's say it is going to become s2 t2 minus it becomes plus s1 t1 equals I think it's s1t, right? s1t minus okay, it becomes plus s2t. Let's say in this case t is common, let's combine t into s1 plus s2, right? So it is going to become s2 t2 plus s1 t1. So now in this case what happens is t is multiplying this overall thing, right? I am going to send this to the other side. Now this comes to the final formula. T is equal to s2 t2 plus s1 t1 by s1 plus s2. I think we got a clarity about it, right? So wonderful. This is the second case, right? So if you look at the third case, right? Third case is very simple. Okay, this formula is also used in some problems now. Okay, so coming to the case 3, we have masses. The masses were equal in the third case. In the first case, we have taken specific heats were equal. In the second case, masses were equal. In third case, masses equal, specific heats also equal, but temperatures only not equal, right? So if you substitute the same formula, m2 t s2 into t2 minus t equals m1 s1 into t minus t1, right? Now in this case, we'll put in place of m1 and m2, we'll put m, s1 and s2, we'll put s, right? Let's substitute like this, m s into t2 minus t. Here also m s into t minus t1, right? In both the cases, ms got cancelled out. What will remain? T2 minus t is equals to t minus t1, right? Let's send t1 other side, t to this side. Now it becomes t2 plus t1 equals, t comes over here, it becomes t plus t, which means 2t is equals to t1 plus t2, right? Let's send 2 to the other side, because 2 is multiplying t, it becomes t1 plus t2 by 2. Is it clear? So this is the final formula. So we got 3 formulas here, right? How many formulas we get? 3 formulas, and we have 3 conditions. Okay, so for this we have a condition, that is masses were not equal, specific heats were equal, and temperatures were not equal, right? If you consider these 3 cases, okay, based on the problem we are going to use the formula. Okay, let me tell you with an example, right? So I am rubbing this. Okay, I'll just rub this, I won't rub the formula. So if you consider a person, like, let's say we have a Ramesh here. Okay, so let's say this person Ramesh is holding 2 beakers. Okay, he is holding how many beakers now? He is holding 2 beakers. Okay, in one beaker, in the first beaker, it is filled with water. Okay, in this case also it is filled with water. Wonderful. Both the cases he had taken water, but in this case temperature in the first beaker, let's say it is A and B. Temperature in the first beaker, let's consider it is 20 degrees centigrade, right? And temperature in the second beaker, it might be 30 degrees centigrade, right? Coming to the weight, he has taken mass, might be 30 grams, and here mass of this 2, that is mass m2, it might be similarly equals to 25 grams, right? So if you consider this case, it looks like a condition, right? Here if it is specific, it is same here, that's because s1 is water and s2 is also water, right? Okay, let's try to make a condition. Let's say m1 and m2. If you look into m1 and m2, m1 is 30 and m2 is 25. Is both were equal? Not equal, right? Because it is 30 and it is 25, so both were not equal. Not equal. Wonderful. S1 and S2, if both were water, then it becomes equal. Yes, right? They both were equal. Now coming to the temperatures, T1 and T2, I think they both were equal. No, right? If you look it carefully, it looks like M1 is not equal to M2, S1 is equal to S2, T1 is not equal to T2, right? It looks like this. This condition is followed in case 2. No. Case 3. No. What about case 1? Follows, right? So simply use that formula, you will get the answer, right? Simply just substitute the values in that formula. Let's say T is equal to M1 T1 plus M2 T2 by M1 plus M2. Okay, let's substitute the values, you will get the formula, you will get the answer. Okay, M1 is 30 grams. In this case, the major important thing is units were very important. Okay, while doing it, 30 grams into T1, 20 degrees centigrade, plus M2 into T2, it is 25 grams into T2, 30 degrees centigrade, divided by M1 plus M2, that is nothing but M1 plus M2, 30 grams plus 25 grams, right? If you look at closely, it looks like 3 2s are 6, which means 600 grams degree centigrade plus 25 threes. 23s are 60 and 25 threes, it is nothing but 75, which means overall it becomes 750 grams and degree centigrade, divided by 30 plus 25, it's 55 grams, right? So let's add these two. 600 plus 750, 6 plus 7 is 13, so overall it becomes 1350 grams degree centigrade divided by 55 grams. Now grams and grams got cancelled out, right? So now what is the final thing? Let's say, let's solve this. If you look here, it looks like 1350 divided by 55 degrees centigrade, right? So let's say, let's cancel it with pi table, right? In pi table, 55 goes for and times, I hope so. 1350, which means 2 times 10, 3 is remaining 35, 7 and we'll put a 0, 7 by 35, right? 270 over 11, which means in 11 table, how many times it goes for? Let's say 2 times 22, 7 minus 2 is 5, 0, so 11, 4 times 44, 50 minus 44, it's 6, okay? So we'll put a point, put a 0, in 11 table 66, 5 times 55, again 5 is already point here, 5, 4 times 44, okay, it goes on, right? So point after 2 values were enough, right? So the final answer might be 24.54 degrees centigrade, okay? So this is the resultant temperature, right? This is the final temperature. So if they had asked you, and they might ask you the questions like this now, okay, don't get confused. And the overall, these were very important. Which were the units were very important, because we are calculating the temperature, so you need to get the final formula for temperature, okay? So that is units of temperature per degree centigrade. We got the same units, right? So then only the answer might get correct, right? So be careful about it. Okay, let's do one more. Let's say we have something here. Let's say we have one more girl to represent it. I'll put something here. Let's say she was holding 2 beakers now. In the first beaker, she had taken water again. Now you guys need to tell me. Try to do it at your home, right? So these two were waters, okay, which means S1 and S2 both were equal. Yes or no? Right, wonderful. Now coming here, masses, M1 is equal to 20 grams and M2 is equal to 20 grams. I think masses were also equal, right? And what about temperatures? Temperatures were 30 degrees centigrade in the first case and 20 degrees centigrade in the second case, right? So if you observe these two carefully, it looks like the condition is M1 is equals to M2. Yes, because those two were 20. Specific heats were also equal because those two were water. Wonderful. Coming to the temperatures were not equal. That's because it is 30 and it is 20, right? So it looks like it is case 3, right? For case 3, we have a formula that is T is equal to T1 plus T2 by 2. That's it. Final. Okay. Direct formula. Let's substitute the values. We'll get the answer. So T1 30 plus T2 20 by 2. It is nothing but 50 by 2. Right. So if we look here, 30 degrees centigrade and 20 degrees centigrade. Overall 50 degrees centigrade. So half of 50 is 25 degrees centigrade. Right. So while they had given this kind of equation, for suppose you might forget the formula. Right, you only remember first case, right? Only this formula is used in this situation also, right? So let's substitute the same values in the first case, right? Let's say T is equal to m1 t1 plus m2 t2 by m1 plus m2. Let's substitute the values and see the final answer. M1 value 20 grams into T1 value 30 degrees centigrade plus m2 value is 20 grams and T2 value is 20 degrees centigrade divided by m1 plus m2 is nothing but where 20 plus 20 grams plus 20 grams, right? So 2 3s are 6, which means 600 grams degree centigrade plus 2 2s are 400 grams and degree centigrade. 20 plus 20 is 40 grams. Overall 600 plus 400 is 1000 grams degree centigrade divided by 40 grams. Grams and grams got cancelled out and 0 and 0 goes. In 4 table 100 goes for 25 times. I think we got the same answer here, right? Yes or no? In the both the cases also we got the same answer, that is 25 degrees centigrade. Yes or no? So this formula is also be used for some cases like this. Okay, if specific heats were equal, masses were also equal and temperatures were not equal. Okay, if you forget the formula, if you forget this formula, then you could use only this formula, no need to worry, right? But in this case, if you do with this formula, you won't get the answer. Let me tell you, here T is equal to, let's try, T is equal to T1 plus T2 by 2, right? T1 is 20 plus T2 is 30 by 2. It is nothing but 30 plus 20 is 50 by 2. It is 25. We got 25, but the answer is 24.54, right? It is not that accurate, right? Yes or no? So this formula is not used for case 1. Okay, for case 3 problem, we could use these two formulas. Is it clear? So try to do it, and I think I would like to say one more problem based on case 2. Let me tell you that formula, that also. It is not that very important. Every time in examination, they might ask you this question. Okay, formula problems might be based on this formula, or else might be based on, okay, case 3, right? So let's say we'll deal with one more time. We have one more girl here. Okay, the girl is standing and holding one with ice cubes, right, and the other with water. If you look at carefully, what is going to happen here is masses coming to the specific heats were not equal. That's because ice has a specific heat value of 0.5 it's joule per kg Kelvin, right? So in simple terms, we'll take CGS units, right? It is calorie per gram degree centigrade, right? 0.5. So here for water, its SI unit is, sorry, for specific heat CGS unit is calorie per gram degree centigrade, right? So these two are, and here we'll take, as you guys know the condition, masses would be equal. M1 is equal to 20 grams and M2 is equal to 20 grams again, right? Masses were equal, and finally temperatures were not equal, that is, okay, 10 degrees centigrade and T2 is equal to 5 degrees centigrade, right? So let's say in this case it looks like case 2. We have a formula, T is equal to S1 T1 plus S2 T2 by S1 plus S2. Let's substitute this also, right? So if we substitute in these cases, S1 has a specific heat value, that is 0.5 grams degrees centigrade, okay, 0.5 calorie per gram degree centigrade into T1 10 plus S2 1 calorie per gram degree centigrade into T2, that is 5 degrees centigrade, right? So divided by S1 plus S2. S1 plus S2, that is nothing but 0.5 calorie per gram degree centigrade plus 1 calorie per gram degree centigrade. In both these cases, let's multiply. It becomes 0.5 into 10. Half of 10 is 5 calorie per gram degree centigrade plus 1 5 are 5 calorie per gram degree centigrade divided by 0.5 plus 1, that is 1.5 calorie per gram degree centigrade, right? So if you add these two, you get, so here we have degree centigrade, right? So in the first case we'll have degree centigrade squares. Okay, I think degree centigrade could cancel out here. Yeah, so there is no need to worry. Now in this case we have something, 5 plus 5 is 10 calorie per grams divided by 1.5 calories per gram degree centigrade. Calorie got cancelled out and grams got cancelled out. What will remain here? 10 divided by 1.5. Here coming to the units, there is nothing, 1 by degree centigrade, which means degree centigrade goes top. It becomes, so let's do the same thing to this also. It comes like this, 10 by 1.5, which means 15 by 10. Let's write like this, right? Because point after one value, so we'll put 10. So we'll send 10 to the other top. It becomes 10 into 10 by 15 degrees centigrade. 10 tens are 100 by 15 degrees centigrade. In 15 table, does 100 goes? Let's cancel it with 5 table. In 5 table, it goes for 3 times and 20 times. So let's do this into 3 table 20. 3 6 are 18. 2 will remain. We'll put a point and 0 6 are 18. Okay, 6 will be goes on continuous. It becomes 6.67 degrees centigrade. That's because we got 6.6 bar. So to remove the bar, we'll put the next digit, right? So it becomes 6.67 degrees centigrade. I think it's very clear, right? So the process is very simple, right? But you need to know the formula. Is it clear? So this is all about principle of method of mixtures. In the coming video, okay, we'll deal with specific heat of a solid experiment. Clear? Thank you.